Hey guys, Mr. Brown here. 6.6 conditions of special parallelograms. So given that something is a parallelogram, in this video we're going to learn how to determine if that parallelogram is a rhombus, a rectangle, or a square by looking at their diagonals and a couple other of their attributes. So how to determine if a parallelogram is a rhombus, rectangle, or a square. And so one key thing here is that all of these, it's given that it's a parallelogram, meaning that we know that the opposite sides are congruent, we know that the opposite angles are congruent, we know that opposite sides are parallel, and we know that consecutive angles are supplementary. They add to 180. All of those elements, all of those properties of parallelograms count for all of these. These are just special types of them. So if we already know that it's a parallelogram, how do we know that it's a rhombus? Well, the simplest way is if we know it has 4 equal sides. And that is true for any shape that has 4 equal sides. Any quadrilateral with 4 equal sides, it is automatically a rhombus. So if I can show that, boom, done. Otherwise, if it is a parallelogram and we look at the diagonals, the only parallelogram that has diagonals that meet at a 90-degree angle that are perpendicular to one another are rhombuses. So diagonals are perpendicular. The other way that we can tell this, there's another way we can tell whether or not they're perpendicular, and that's if our angles are bisected. So if those diagonals bisect the angles, angles are bisected by the diagonals. If we know that, then for sure this is a rhombus. Okay, so a rectangle. How do we tell whether or not a parallelogram is a rectangle? Now again, I know these, it's given that these are congruent, these are congruent. It's given that these two are parallel, these two are parallel. I can tell this is a rectangle if I know that all 4 angles are right angles, or 90-degree angles, right? If it's a parallelogram, if it's a quadrilateral with right angles, it is automatically a rectangle, right? Now, the way I can tell that using the diagonals is these diagonals are congruent. They're not perpendicular, but they're the same length. That only happens in a rectangle. So the diagonals are equal. Diagonals, meaning that if we measure across, that it is congruent diagonals. We'll maybe go make it like this. That might be a better way to think of it, that all 4 of those parts are all congruent. All right, how do we tell if it's a square? Well, a square is actually kind of the combination of a rhombus and a rectangle. All 4 sides are equal and all 4 corners are 90-degree angles. So 4 equal sides and 90-degree angles. Right, so all 4 sides are equal and we've got 90-degree angles. So how do we tell this with the diagonals? Well, it is a combination of our rhombus diagonals and our rectangle diagonals. So the diagonals are equal. And perpendicular. Also, right, if we know that the diagonals are perpendicular, we could also show that if Not only if we know that they're perpendicular by finding like that it's a 90-degree angle in the middle, but if they're equal and they bisect. So perpendicular or bisect the angles. Okay, so let's take a look at some examples determining whether or not it's a rectangle, a rhombus, or a square. And notice that in this it says, do not trust the picture, right? We need an explanation. We're not going to trust the picture. We're only going to look at what's given to us. Okay, so for this one, we know it's a parallelogram. I can tell it's a parallelogram, one, because I think it's given. So determine if the parallelogram is a rhombus or a square or a rectangle. But looking at this one, I know it's a parallelogram because we've got opposite sides that are congruent, right? Now, is it a rectangle? Technically on this one, I don't think we have enough information, right? But I think the idea with this one is that the diagonals are congruent. So let's add a little bit to this, right? I think that's what they're going for with this diagram, with those diagonal lines, is showing that the blue and the red diagonal are congruent. So we could say that this is a rectangle. And our reasoning is that the diagonals are equal. All right, moving on. We've got in our next one, well, it's 4 equal sides, so that is automatically going to be a rhombus. There's actually 2 right answers to this one, though. It's a rhombus because for this parallelogram, it's got 4 equal sides. Or we know because the diagonals are perpendicular. Diagonals are perpendicular. All right, and then our last one, well, this is a square. And I know that because it's 4 equal sides. And 90-degree angles. All right, moving on to our bottom one. Now this one, we don't have enough information. It certainly looks like a square. We maybe think it maybe looks like a rectangle because we've got opposite sides and it kind of looks like a 90-degree angle there, but technically we don't have enough information for this one. We know it's a parallelogram based on the opposite sides being equal, but it could be that it's just ever so slightly off, right? And so it's not making a rectangle because it's just a little bit off like that. I just wanted to kind of exaggerate that a little bit to show why we don't have enough information. All right, then over here, this one, well, we've got 4 equal sides, but we don't know anything about the angles. We don't know anything about the diagonals. So all we can say is that this is a rhombus because it's 4 equal sides. And then our last one, it certainly looks like a square, but I don't know like if these 2 sides are actually the same as the top and bottom sides. It could be that it's just a little bit taller than it is wide, or the other way around. So the best I can do with this one is say that this is a rectangle, and that is because it is 4 90-degree angles, or we'll just say 90-degree angles.